have another way. It's the same way. Just replace this by what? Is there another notation for y prime that we've been using for implicit differentiation and for others? Is there another notation for y prime? We've been using it all along. Yes, and another one. Correct. Perfect. It is f prime of x, but there is another one that we use for implicit differentiation. I said don't use this notation, but use the other one. Anyone? What is the other notation? Right, y prime, f prime of x, and the other one is? We wrote it today also, a few minutes ago.
I think someone said dy.
But dy is the differential. It's not the derivative. I didn't hear that. I'm sorry, my apologies. I cannot write dy.
Maybe d of u?
No. No. So let me go to the first page. Can anyone tell us what is the other notation for f prime or y prime? Exactly. Thank you. Very good. So dy over dx, this is what we used for implicit differentiation. We did not use that, we used this. Equals 3 over x plus x squared minus x to the fourth. And how do I get to what we just did? By simply multiplying both sides by dx. Same thing. So dy equals 3 over x plus x squared minus x to the fourth times dx. And now integrate both sides, which is exactly what we wrote initially. We integrated both sides directly. But now I wanted you to see where the dx is coming from. Where is it coming from? From this notation. From this notation, which is dy over dx. So this or this are the same. So dy over dx equals this. We multiply both sides by dx, and then we integrate both sides. Like we differentiated both sides, and so on and so forth. Good. So when I differentiate this, this is 1. So the answer is y, because y prime is 1. Now here, which function prime is 3 over x plus which function prime is x squared minus which function prime is x to the fourth, and of course plus a constant c. And I'm given that y of 1 equals -4, helping us determine c. But we have to identify these functions. The function I differentiate to get this, the function I differentiate to get this, and the function I differentiate to get that. Anyone would like to help?
Would the first one be 3 natural of x?
Yes, but don't forget the absolute value. Yes. Perfect.
And then the other one would be x cubed over 3.
Excellent. And the last one?
Minus x to the fifth over 5.
That's it. Done. Now we have to plug in 1 to get c. So when I plug in 1 for x, I get y to be -4. So -4. We know natural log 1. Again, what is natural log 1?
0.
Perfect. 1/3 minus 1/5 plus the constant c. I have to move everything to the other side to get c. So then c equals -4 minus 1/3 plus 1/5. I find that the least common denominator is 15. This one needs a 15, this one needs a 5, and this one needs a 3. So I think that this is negative 60, and then minus 5, and then plus 3. So this is negative 2, so C equals negative 62 over 15. I have to go back and put it in. Let's stop for a moment and see if you have any questions. Anyone, please? Any questions before I put it back in? Any questions? Okay, so let's finish it up and then look at the last type, which is separable. Of course, more work. So then we have y equals 3 natural log of the absolute value of x plus x to the third over 3 minus x to the fifth over 5 minus 62 divided by 15. And this is it. No, nothing is different from chapter 4. Finding the most general antiderivative, and if we have an initial condition, then we found the unique function whose derivative is given to us, this one, whose derivative is given to us, and also passes through the point 1 comma negative 4. So this is a unique situation. And now let's move on. Unless you need more practice, unless you have questions, I'll stop. Any questions? Okay, I would like in that case to move on to the last, I would say, last difficult topic of this class. I think this is the last one. The rest you will see, chapter 6, I think is going to be a breeze. I hope. Okay, solve by separating variables. So let's choose, and we have more here, and then we look at a word problem. Solve by separating variables. I'm going to start with 31, and then you choose the next one. In 31, we have dy over dx equals 5x to the fourth y. First of all, before we even attack this problem, by separating variables it means all y on one side equals all x on the other side. They cannot be mixed and matched. Here I have y and x. No. Here I have x and y. No. So I want y alone on one side, x alone on the other. The first thing I need to do is multiply both sides by dx, like we did a minute ago. So then dy equals 5x to the fourth y dx. Now, I'm happy with this. It can stay on the right-hand side. I'm happy with this. It can stay on the right-hand side. And I'm happy with this. It should stay on the right-hand side. But I'm not happy with this. This does not belong on the right-hand side. What should I do in order to, only something that is legitimate, of course. What is the legitimate operation that will remove the y from that side and bring it somehow in some shape or form to the left-hand side? What operation I should use to get rid of y from the right-hand side?
Can you divide by y?
Absolutely. It's the only way. I have to divide by y. So when I divide by y both sides, I get dy over y equals 5x to the fourth dx. Yay! I separated the variables. Everything that has y is on one side. Everything that has x is on the other. Now I'm ready to integrate. And let's start with the left-hand side. Which function prime, of course you remember how to see this. When you look at this, you should see 1 over y times dy. You should see 1 over y times dy. That's what this means. Which function prime is 1 over y?
Natural log
The absolute egg.
y.
Brilliant. Okay, see? With enough torture, you will remember. Thank you. Awesome. We are done with the left-hand side. This is an equation. We cannot continue to the sides. There is one left-hand side, there is one equal symbol, and there is one right-hand side. 5 is 5. The function whose derivative is x to the 4th.
X to the 5 over 5.
Very good, since it's an indefinite, plus a constant c. I simplify these two by 5 and I get 1 and 1. So now the equation is natural log of the absolute value of y equals x to the 5th plus c. This is good, but not good enough. Now I have to use algebra to solve for y. Now we have to dig deep. Not that deep, it's chapter 3. We solved these equations in chapter 3. Let me start a new page and copy this because I don't have enough room. So, natural log of the absolute value of y equals x to the 5th plus a constant c. I need to solve for y. So, remember the base here is e. So then the absolute value of y will be e to this power, e to x to the 5th plus a constant c. Is everyone comfortable with this step? You remember this step, or you need me to explain more?
Can you explain more?
Yes, absolutely. I'll come back to it. When we discussed chapter 3, and this was also done in 137 course, we said that a very important relationship is any logarithmic equation can be converted into an exponential one. Base raised to this power equals x. This is the procedure that I used. A raised to y equals x. So this is a log equation. This is an exponential equation. A raised to y equals x. A raised to y equals x. Again, a raised to y equals x. Base raised to this equals the absolute value of y. Is this better?
Yes.
Perfect. So, we have to take this one step further. First of all, I have to remove the absolute value. So I will write y equals plus or minus, because that's what this means. And we have to separate this into two pieces. So let me refresh your memory. If I have a raised to n plus m, it's the same with a to n times a to m. They go both directions. 2 to the 3rd times 2 to the 4th, copy the base, add the exponents. But I can also go backwards and separate it into two factors. Same thing here. E to a plus b equals e to a times e to b. If I want to go back, I copy the base and add the exponents. We will replace this by another constant. So it's a constant. If you can call it c, you can call it a, you can call it c1, whatever, it doesn't matter. So then the final answer is plus or minus some constant e to x to the 5th. So y equals plus or minus a constant c or c1, it doesn't matter, e to x to the 5th. This is the solution. To what? To this equation. we determine the function that fulfills this condition, that its derivative equals 3x to the fourth times the function. This is not trivial. I consider this the most difficult topic in this class, from everything we've studied. Not to scare anybody. The problems are not difficult, but it's step after step after step after step after step, as you've noticed. Some of them are easier. So let's continue practicing with others. Okay, back to the book. Okay, so let's choose something else, like, I don't know, 37, or you choose. I'm on page 6. 37. dy over dx equals 7 over y squared. This is an easier situation. You'll see in a moment why, and we can choose others. Okay. What do you think is the first step? It's okay if you're wrong. I promise you nothing will happen.
Put the x on one side, the y on the other.
Very good. How will you do that? Excellent. Any suggestion that will accomplish that step quickly?
Multiply y squared.
Yes. I would say cross multiply because it's a proportion. But you are correct. Multiply by y squared and then multiply by dx. But just cross multiply. dy has to be at the end always. So y squared dy equals 7 dx. Yay! They are separated. Y is alone, everything with y is one side, everything with x is on the other. What do we do next? What will be the next step? We separated them, now what?
Solve for y.
You mean integrate. We integrate the left-hand side and we integrate the right-hand side. Awesome. Which function prime is y squared? Because I know it's confusing, that's why I cover it. Which function prime is y squared?
Y 2, 3 over 3.
Excellent. Equals. Notice that we only put one c. You can say, but wait a minute. I forgot to mention that. I want to go back for a second. You can say, but what is your c here? Why did you put c only here? This c with this c create another c together. So there is no need to put a c on both sides. C is only one side. Good. Which function prime is 7?
7x.
Yes. And here I will write plus c. There is no need to have c on both sides because you can subtract this c from this c and you get another constant. Good. Now algebra to solve for y. What should I do first? I'm solving for y. What will be the first step towards solving for y? What would you do? Forget about calculus, it's just algebra now.
Multiply both sides by 3.
Very good. So y cubed equals 21x plus 3c. Excellent. Final step, I'm solving for y. What should I do to both sides to get y?
Multiplied by the, multiplied by, the 1/3 power.
Yes. In other words, you're saying take the cube root from both sides. Correct. And there is no plus or minus for the cube root. 21x plus 3c. Done. Why was this problem easier than the previous one? Because we did not have to look at something like this. Change the logarithmic equation into an exponential one in order to solve. So that was the algebra that was more difficult, but not the calculus. Okay, this was easier because the algebra was easier. Okay. Let's choose another. Anything from 31 through 42. Now notice here, this is different, it's slightly different. So let me know if you want to work on another problem here. Here we are given the initial condition. Y of 0 is 5. Y of 0 is 9. Y of 2 is 3. Y of 1 is 3. So here, they don't want the general function. They want the function that fulfills the given conditions.